Hi, my name is Stevie from the Sensorica Lab with the Sensorica Open Value Network. This video is an update for a project within the Sensorica network that we started more than a month ago. It's about a food processing, and I'd like to give you a little bit of some updates about how this thing moves forward and the new realizations, the new learnings that we have acquired at this particular time. Let me switch here to the project page. The name of the project is Leaves Blender. We are also in the process of rebranding this project, and you'll see why. And later on, if you come and you search Leaf Blender, you will probably find a dummy page that will, with a link that will help you find the newly branded Leaf Blender project. So this is about designing and prototyping a food processing device at a village scale. So it's not something that is meant to be used by a family, and it's not something to be used in an industrial context. It is about designing an open source and do-it-yourself piece of equipment. To get familiar with the project page, you have the objectives and the description of the project. You can go more in depth. If you already don't know about this project, you can also find us on Discord if you want to get involved. And you can look at the planning. You have all the documents that we're working that are related to this particular project in the planning. And well, you can also go to the dashboard page to see how people are contributing and who is involved. The other type of contributors, the partners that we call for this particular. So you see the budget, how it is distributed in different work packages. You see how we are burning money from the budget. Again, you see the planning here on the left. It's important to read this text here to get an idea about what happens once you get involved. You can see the different type of participants, and if you want to see what contributors are doing and how much they're doing and in what capacity, you go to this particular section here. I'm not going to drill down because this is not about steering the project. This is more about how the project has evolved and where we are at this particular time. So a bit of background on this. This project has been proposed to Sensorica by Joshua Pierce, a professor at Michigan Tech University, and the original goal was to design and build a prototype, a device that processes green leaves, and extracts proteins. Now, leaves don't have a high protein content, so usually they're not part of the staples that we use to get food. In normal times, we go to agricultural products that are very rich in protein, like grains and beans and peas and all that. But what happens when agricultural supply chains are disrupted because of a war or any other types of crises, environmental, medical, a pandemic, whatever, what happens when we cannot get access to protein-rich staples? Then the idea is that within our environment, there's still a bunch of green leaves that grow wild, which are a source of food. And if we have a method that could efficiently extract these proteins from these green leaves, then we could eventually go through the crisis. So this would be a lifesaver device when times are rough. So that was the original goal, and then we thought about this, like, how could this really be implemented? Okay, how can we build a device that is to be used in times of crises? It's a pretty complicated device. So one of the models could be that we make a design that is easily you could easily reproduce this prototype based on the CAD files. The design could be made in such a way that the local suppliers could make available the parts. Okay, so you don't have to rely again on global supply chains to get parts to build this device. It would defeat the purpose. So, you know, we could put this design out there on the internet, and we have to make sure that people know that it exists. And in times of crises, some of these locals would download it and make the device and use it to solve their food problems. Well, that's problematic. It is problematic because it takes time to build such device. It requires skills. So you have to think that during these times of crisis, there is people that have enough time and are willing to build this device. And you know, if we're thinking about a region that would be affected, you would need a bunch of teams of these people that build this device, that have the required technical skills. You can reduce the requirement of technical skills if you do a clever design, but you still need people with a minimum experience on, you know, electrical systems and mechanical systems to put this thing together, right? You also need the availability of some shops, metal shops, or I don't know, spaces like Fab Labs and maker spaces, or some university shop that would help you process these materials to build this device. Then another problem is that once you have the device, you have to teach people how to use it. Okay. Could that be done in an effective time? All right. There's also the problem of the compatibility between the design and the local environment. How do we know that such design can actually be implemented in a rural area? You know, you build it in a city, you bring it to a village. How do you know that this device can be powered? Is that village on the grid, or is the grid still functioning? Okay, we don't know. So this model of having a design sitting on the internet, there is this gap of going from the design to the practical use of the device. Is this huge gap that might be problematic in times of crises. Okay, the response time might be too slow to solve the nutrition problem that these communities might struggle with. Another model is to actually produce these prototypes and store them in some warehouses. We would think that governments would do that, or some NGOs. And then the problem is the economic incentive for these organizations to reproduce and store the device, the costs associated with that. And then you still have these problems of training users and the compatibility with the reality in the rural area. If you have it stored somewhere and you put it in a truck and drop it in the village, you still need to train these people to use it, and you still need to find the proper way to power the device, right? What if the device breaks? Is there in vicinity someone that is trained to fix it? Someone that knows how to rebuild the parts? Okay, so you still have this gap even if you store the device. Another thing, another way to think about it is to have people in the village build the device and use it for processing green leaves and extract proteins and use it on a daily basis. We had a meeting with Leaf for Life, who are pretty experienced with this kind of leaf protein extractors. And one of the main problems, they started this project in the 90s, one of the main problems was the economic incentive for villagers to operate such device, because the yield of a leaf protein extractor is pretty low. The protein content in leaves is pretty low. So in normal times, when we have access to protein-rich staples, it doesn't really make sense, economic sense, to process leaves. And there is also some other problems associated with that, is the seasonality of leaves. They're not available always. It's also the requirement to process these leaves very fast, because fresh leaves, they don't stay fresh for a long time. Some people have worked on getting the leaves and then drying them and then processing them to extract the proteins. That works, but you're adding another step to it to be able to store these leaves for a longer time. So there are logistical problems and economic problems when thinking of adoption of such devices by people in the village. So we have considered all these options, and I think the best one that we have arrived at is to have a device that is designed to extract proteins from greens, okay, as a first function. But at the same time, it can do some other things. And so there's this idea about building an equipment that people need on a daily basis, a sort of a food processor that they're using for something else. And in times of crisis, this thing could be switched to operate as a leaf protein extractor. Okay, so there would be an automatic incentive for people, for villagers, to use this device on a daily basis, and at the same time, it still maintains this capability of being switched to a protein or green protein processor extractor. If we do it in this way, because it is already adopted, the device is already embedded into the local ecosystem, meaning that the users of the device, they already have built connections with people that can repair it, that can maintain it, that can build a new one. It is already compatible with the power system, and they probably even have backup systems because some people in rural areas, they already run other operations that require power, and they probably have some backup systems for these ones. So if it's made to be compatible, it goes into the same type of logistics. Okay, so you eliminate the problem of the compatibility, because if the device is adopted in a local region, it is already integrated into the local ecosystem. Okay, and when we talk about the skills or the training required, well, the device being used every day for other purposes means that these people have the proper training, the proper experience with it. Okay, so you're not facing the challenge of building the skills in times of crises. So we think this is a more viable approach to this goal of having a protein extractor. And so looking around at different machines that are used for processing food, we have arrived at the idea of extruders. Extruders are these new devices that are very generate a lot of interest nowadays in the food processing industry, and they're used, for example, to make textured plant-based protein, things that have the texture of meats. If you want a basic example of an extruder, is your meat grinder. Okay, there is a hopper, a place where you insert something, the meat, and then you turn a screw, which is a conveyor that drives the meat to a knife and exits through a die. And this can be modular and can have other functions, so you can turn it into a sausage maker, but that is the basic example of an extruder. Okay, it's something that takes some some material from one side and processes it inside and speeds up or exits some process that some of that processed material. They can be very complex. They can be made modular. And another type of extruder is the oil extractors. Okay, same type of thing. You have a hopper. You have an intake where you put your olives or you put your sesame seeds or nuts, and then they're taken by this conveyor screw and they reach a region where they're squeezed, and any liquid content, water and oil, comes out of one side, and your drier fiber material comes out from another side. So we can think of having this project, we can think about it in terms of this kind of generic design of an extruder that could be used by people locally to extract oil. It could be used to grind stuff for different purposes, grains. And at some point, if this device is made to be modular, it can be just turned into a protein plant or green protein extractor. So that is the realization, and now you can see why we're thinking about rebranding the project from Leaf Blender to something else that conveys this idea of a modular universal food processing device, village size, village scale type of thing. You go to these rural areas and you find commonly shared devices or resources like that. For example, corn meals. So what we're looking for now is we're talking to potential users, we're talking to local communities, and we're trying to identify these food processing activities that are very labor intensive, take a lot of time, are repetitive, meaning people are doing these activities on a daily basis or a few times a week. And also another requirement is that almost everybody in that region or in the village does the same thing. Okay, so if you replace that labor intensive work with some type of device, you're saving a lot of time per family and per village, and therefore it makes sense to have a village scale food processing machine where people can bring their stuff and get their end product out of that. And that's the model of the corn meal that you find in several rural areas, because it doesn't make sense for every family to crush their corn at home, which is an activity that they do repetitively. It is labor intensive and everybody has to do it. So it makes sense to centralize that kind of activity and have some type of organization, an association or a co-op or maybe an individual to provide that service for the entire community. So that is the kind of a model that we're thinking about this. And instead of just processing grains or grinding grains, you can have beside that meal, you could have an extruder that could be designed to do 2 or 3 things that are these type of activities that we're looking for very well. And so there is an economic incentive to build it and to operate it. Well, when the supply chains are disrupted, then you just have to change a few modules and turn it into a green leaves protein extractor. Okay, that is the realization, and you can see this shift of our understanding in the design process in our documents. These are the work packages This is how the project is planned, it's structured. And if you open this document right here, just click on that. I have it open here. You can follow our development path. So we have gone through design consideration. We are into design consideration section. We went through building understanding, where we contacted a lot of local communities, NGOs, and even companies, private companies that manufacture equipment for food processing that serve the food industry. We did some information mining, understanding about protein extraction and concentration. And now we are at this particular phase here for general considerations, where this is a conceptual work. I'm going to go there to the section. This is a conceptual work. It's a sort of a meta design thinking, where we kind of fix some other requirements. So there is a growing consensus that this device, it's going to be a extruder. We haven't fully described the requirements of this device, and this table here will help us do that. So for example, we're thinking about the ecosystem in which this machine will be operated. So what is the relationship between this food processing device and everything else around it? How does it interact with the power grid? Or are we going to use some oil-based, like motors, power? How does it interact with some other things around, other devices? How does it interact with the local government and the village governance and all that, right? We're going to think about the life cycle of the project. How is it built, used, upgraded, and in the end, what do we do when it's out of service? We think about the business model or the economic model behind it. Who's going to be incentivized to build and maintain these devices? Maybe the individuals that run the local corn mill in the village might want to expand their operation and add a protein extractor and a food processor and extruder next to their mill, because they already have an established economic model going, and they are connected to the power source, and they probably have some backup system, and they probably have relationships with local shops and other people that have technical skills to replace parts and so on and so forth. So that would be probably a vector of dissemination of this particular device. But that is just one model. There could be other business models or economic models on which this thing could be built, and the design is very intimately related with that value offering model. We're also gonna think about production and dissemination. How is this going to be produced? Is it gonna be made by somebody in the village and sold with some to the villagers? Is it gonna be made in the city and sold to the villagers, or is it the type of a do-it-yourself device? How is it gonna spread? We're building relations with NGOs and local communities and innovation type organizations to be able to make people aware of that. The dissemination is also very intimately related to the value offering model. We're thinking about the system itself. What is the relationship between every part of this particular device? We're thinking about the environment in which this device will evolve. Is it going to be installed in the local corn mill building? Is that the type of environment? What about the temperatures? Is it going to be used outside, inside, so on and so forth? And also user effects. How can people use this device in a safe way, and also in a way that doesn't destroy the device? Okay, so all these considerations go into the design once we have figured it out. So there you go. These are the updates for the Leaf Blender project. If you haven't joined the project yet, just go to the project page and click on join the project. Again, this project might change name, as we are thinking about rebranding it to communicate this idea of a sort of universal food processing device that could be repurposed and serve as a life-saving leaf protein extractor. Thank you for your time. Hope we see you on the Discord channel.